Hello, my name is Sergi Baila. I'm a software developer with over 20 years of experience. I've been using Java since 1999. Currently, I'm a blockchain developer at Gelurida, where I work on the core products Ardor and NXT. So for many years, I worked developing custom applications in Java, always in the form of web applications. Eventually, I grew tired of the internal custom development environment, so a few years back I decided to look at for a change. So I knew the blockchain technology on a very basic user level, and I was very happy to find a place in Gelurida with the creators of the first blockchain written from scratch after Bitcoin, and 100% pure Java based. So I guess most of you are familiar with what a blockchain is. Anyway, let me do a quick recap. You can think of a blockchain as an immutable distributed ledger. So it's a ledger because it keeps track of entries or events. We call those transactions. It can be a transfer of value between accounts, like what Bitcoin does, but you can actually store any kind of transaction, like casting a vote on a poll, sending a message, or storing some data into the blockchain. It is immutable because entries can only be added to the ledger, not modified or removed. And it is distributed in the sense that every participant has a full copy of the ledger, so as no participant is different from each other, it's decentralized. So without any kind of centralized authority, you can only rely on validating everything yourself. That's the basis of the blockchain. So these transactions are put together into a new block. Each block points to the previous block. So we form a chain of blocks, hence blockchain. So a blockchain has a set of rules that define which transactions are valid and how they are processed and put into blocks. That's usually called consensus because they are the common rules followed by all parties on the blockchain. So each block is built by a single entity. Choosing who creates the new block is part of what's called the consensus algorithm. You surely have heard about Bitcoin mining and proof of work, but there are alternatives. So the Ardor platform is the evolution of NXT. NXT was envisioned as a next generation blockchain. So actually NXT comes from next. Instead of just a transfer of value, it provides lots of built-in features that implement most of the use cases found in blockchain business. You can think of it as built-in smart contracts. NXT was built in 2013, but development didn't end there. In 2018, Gelurida launched Ardor, building on the solid foundation of the previous project. Ardor adds many future-proof features like multiple chains, permissioning, snapshotting, or lightweight smart contracts. So today, I want to introduce the Ardor platform to you. Okay, so let's take a look at the Gelurida's website where you can download the software. So this website you can find of course all the information and so on about this the Ardor blockchain, the previous one, as I've said, the NXT. So let's focus on the Ardor downloads. So here you can see you can download the current version, the current production version 2.3.3, and an experimental version. And you can find here installers for the different operating systems for Windows, Mac OS, Unix, and the universal zip package. So this, as I've said, this software is written 100% in Java. So the software that you download here has all the code necessary for the blockchain implementation, the consensus for the security of the network, the peer-to-peer networking between the nodes. It it also has a wallet, a web wallet and a desktop wallet integrated, an API. Everything is in the same single package, and it's 100% Java code, open source, of course. So why, if it's 100% in Java, why do we have these different installers? So it's just because we usually bundle, for example, the Windows one, it bundles OpenJDK. So for the regular user that probably doesn't have Java installed on his system, the software uses JavaFX for the desktop wallet, as we will see. So that requires some platform-specific code. But for example, the universal zip package is just the source code compiled in Java, so it doesn't bundle any JDK, any JavaFX. So this is, for example, if you just want to do a manual installation, this is the one to go. So now I will download and install the Java version, but I will skip this for you because it's really easy, and let's continue after that. Okay, so let's start it. So you can see this is starting the Ardor desktop. It just started, so it has no connection to the blockchain, so still getting some connection. This will won't take long. So you can see here that it's already connected and downloading blocks. So if you just do the installation by yourself, you will find that it will take several hours to download the whole blockchain. So that's how blockchains works. It needs to download all the history and verify itself. So you can see here that I'm just finishing the download. That's because I did a bit of a cheating, because I downloaded a blockchain database from Jelly's website. It's also available in the same page I showed you earlier in the Ardor downloads. If you're using a mainnet node, it's always better to just rely on the node to download the blockchain by itself. Let me take a step back and talk a bit more about the architecture of the software. As I've said, the single application packs all the different features and components, as you can see here. From the core itself, I want to highlight a few key components. We use H2 to store the SQL database built from the data on the blockchain. It provides a structured and easy access mechanism for queries. As a blockchain platform, Ardor relies on a decentralized peer-to-peer network of nodes. These nodes communicate using a regular TCP socket with a custom binary protocol designed to be as lightweight as possible. Remember that the whole ledger is distributed to all nodes, so all transactions and blocks should be sent to all nodes. It is important to pack as much information on as little space as possible. The Jetty embedded web server makes it easy to build an HTTP interface that serves two purposes: the RESTful API and the static assets for the wallet. This API is the interface that all external entities use to interact with the node itself, including the wallet itself. You see, the wallet is just a web application built using a standard HTML, CSS, and JavaScript. The client-side JavaScript code uses this same API to communicate with the node. Of course, you could use just a regular browser, open the HTTP port, and access the wallet. But in order to provide a native desktop wallet that doesn't rely on installed browser, which can leak some information or be vulnerable to malicious plugins, we just use JavaFX to create a simple web view window and embed this same HTML wallet. This is basically a Java command line application, which NXT class, which has the main. So that's how you run it. So when it launches, it uses several components, mainly two big components, which are the Jetty embedded web server, which is used to serve the static files for the desktop wallet, like the HTML, CSS, JavaScript that I said. And you can see it's just standard HTML, JavaScript, and so on CSS files, but also a servlet to, of course, implement all the APIs that that expose the features of the platform. So Jetty started like from this subsystem, which is called the API, and basically read some properties about the configuration, about ports, network interface that you want to listen, if it's SSL, and the certificate, and so on. So it starts this Jetty with the different ports that you need. So also we have, as I've said, the desktop, what we call the desktop version is a JavaFX application that's basically a web view that basically loads the same HTTP version that you can load on the browser. And finally, another very important, you can see here the libraries that are included. Another very important part is the H2 database. So you know it's H2, it's an 100% Java embedded database, SQL database. And why do we need a database on a blockchain? When you load that blockchain, you need to keep some kind of state. You need to know different accounts, the balances of the accounts, the different transactions, and so on. Of course, you can just load the blockchain, but in order to have it in a easy to access and fast way, of course, you need to process the blockchain and keep updating this state that you can see at any given time. So for that, we use a regular database, embedded database, that we store in the disk, but it's running embedded into the node. So for that, we use H2 that provides a very good performance, and of course it's written in 100% Java, so it can run the same code on any of the platforms. An interesting fact about this code, if you take a look at the source code, you will see we're not using Maven or Gradle or any build system, because when you're developing a blockchain product, you need to be especially careful about vulnerabilities and security. So when we want to update and include libraries, we need to be very careful about verifying that the library hasn't been compromised and so on. So we're not relying on some automatic build system. So each time we need to update any of the libraries, it's done manually. We go to the website, we verify the binaries are okay, and we add it manually to this directory and so on. So it's a bit more work, of course, but it's worth the extra safety. So let's back to the wallet, and let me show you a quick introduction of the wallet and the different built-in features. So the first screen that you see here is the login screen, where you can create a new account that you don't have any, or you can log in with an existing previous account. So you can see here, like, you have 4 different options to create or log in with an account. The 2 rightmost options are the legacy accounts from previous versions of the software. But since then, we've implemented support for the wallet to connect to hardware wallets, like, for example, the Ledger hardware wallet. So this other tab is just for that. While we were doing this integration of the hardware wallet, of course, hardware wallets operate with some standards like BIP32 and so on, that it's commonly known as the HD wallet, which basically it's like a seed between 12 and 24 words, and that allows you to basically create an unlimited number of derived accounts from a single secret, in this case, the seed. We also implemented a software version of the same feature, and that's this seed first tab that allows you to create the same HD wallet but entirely on software. So let's use this to create a new account. So I click on create. By default I can change the number of words. 18 is fine for this this new test. So let me usually we will write down on a safe place, but for now I will just copy it to notepad somewhere, and then okay, I will not forget. And next step, I need to confirm that I correctly saved my seed. So now the seed is ready, and I can just click load, and it will start checking the different derived accounts from this seed and check if those accounts are actually used or not on the blockchain, and stopping the first one. So as this is a new seed, there is no account used on the blockchain. You can control here about the index of how many are you looking at and the master public key. So this is a bit advanced technical part, but those of you who are familiar with BIP32 and HD accounts will recognize this part. So let's log in and see what it shows. So this is the dashboard of the standard wallet. So this is the information you get on a new account. You have the address here. You don't have any ignis, which is the first child chain. And this is a warning telling, okay, this is a new account. This is your address. You can buy some ignis from exchanges and so on. But remember, this is testnet, so this is not mainnet. So for this, we can get some free to use testnet coins. So in order to do that, we can go to a service which is called Ardor Vault, and then here I can go to Ignis services and click test Ignis faucet, and then I will copy my account, put it here. I agree, I'm not a robot, bases, okay, and I submit. And this service is saying, okay, I've sent you this testnet coins to this account. So let's check, and we can see here already the transfer of 1500 ignis is on its way to my new account. So this is still not confirmed on any block, so height is still missing. So it's finally bundled, so it's included in the last block, and I already have this ignis. So I now have this warning which is related to some internals about accounts. So you can, for now, just ignore it. An easy way to remove this is just to create any transaction on the blockchain. So for example, I can set the name of the account saying, okay, this is the Java Summit test, and I'm using a fee of 2.5 ignis, for example, and the moment I send a transaction and it's bundled right now, so this warning disappears because I've sent at least one transaction on the blockchain. Okay, you can see here that I get a payment. So As you can see, you have this dashboard here, you have here the recent transactions, and to the left I have like the list of all the sections or the features that the blockchain implements. Remember, I talked at the beginning that Ardor is a next generation blockchain, which is not just the transactions are not just a transfer of value, like for example this first transaction that we've made, which is like moving tokens from between two accounts. We have a lot of other features like a coin exchange, which is a decentralized exchange between the different chains of the platform. Remember, this is a multi-chain, so you have Ardor, which is the parent chain. You have Ignis, which is the first child chain, and different child chains for different projects or companies. So you have a decentralized exchange built into the blockchain to exchange tokens between these chains. You have also the asset exchange, which is basically a mechanism to issue assets into the blockchain, have different units, trade with them, send it to another account. You have also an asset exchange. You have properties, metadata that you can associate with the assets. So very powerful feature. You have the monetary system, which is a mechanism to also generate currencies inside the blockchain. So if you want to just have your own cryptocurrency, you can use the platform and you don't need to worry about coding anything or cloning other project and deploying nodes. You can use Ignis or Ardor to just expose your own cryptocurrency. You have a voting system, so you can create voting pools that can be used from the blockchain itself. So you can accounts can cast a vote, and it's all of it's built into the blockchain itself. A data cloud, so you can store small pieces up to 40K approximately of data to the blockchain. A digital marketplace that allows you to buy or sell digital assets. You can list anything for sale with a given price in tokens, like in this case in Ignis, and you can have the workflow of selling, sending, completing the order, etc. You have the shuffling mechanism, which is a privacy mechanism to shuffle tokens or assets or coins from the monetary system between different accounts in a way that's private, and you can get back the tokens without some fees. So it's into a new account without linking to the source account. And also you have messages. You can send messages between accounts, and aliases, like it's like some kind of DNS built into the blockchain, so you can have a global identifier on the blockchain associated to any text or account, for example. About the API we've been talking about, let me show you here. You have on the settings, on the cogwheel settings, you have the API console. This is just opening another web page, which is /test, which is an automatic servlet that exposes all of the APIs of the node with an easy to use interface in order to test and check the different API endpoints. So for example, let's go and copy the address of the account and go back here. These are the sections. So you go to account and get account. I can see here that this is get account is one of the API endpoints, which is a query of an account. You have all these different parameters, and this test servlet just makes very easy to just test the answer that you get from a given API endpoint. So just submit this. You can see here that you have some JSON, which is exactly what you are getting from the API endpoint. So this is very useful as a developer if you are implementing some application that uses or needs to use the blockchain interface with the blockchain. So it's very easy to check here which different API endpoints do you have, and also you can test it. Even more interesting is this little link here, wiki, with when you click it, it will send you exactly to the official online documentation of each one of the different APIs. And in this case, the get account API, you can see here that we have all these different parameters with a description, what means for each of the different parameters, which ones are optional, and also the expected fields of the response. So I want to finish today's presentation talking about smart contracts. So you know smart contracts, probably you have heard about Ethereum's smart contracts when you need to write code for each use case that you want to implement. So with Ardor and NXT, you have a lot of built-in features like voting, like data cloud, like the asset exchange. You can create assets, you can assign metadata to assets and accounts, you can create a pool voting system, you can send messages between accounts, you can set up account or asset control to have a very powerful mechanisms of validation and confirmation. We call it phased transactions. So we have a lot of built-in features that we think cover a lot of the business use cases that you can find and you can implement with a blockchain. So why adding a new concept, which is the lightweight contracts? So in case you need a bit more flexibility, and also because there is a single type of interaction that smart contracts have a lot of difficulty to achieve, which is what it's called oracle contracts. Oracle contracts means contracts that interact with data outside of the blockchain. So this is basically very difficult to do because a blockchain needs to be validated by all the nodes. So even querying an API or a website on the internet can be part of the consensus, because each node that is going to validate your transaction and your block might be seeing a different result or may fail. So historically this has been quite difficult to achieve. So this is one of the key features of the lightweight contracts, that you can implement oracle contracts. So I want to now, before entering into details about the lightweight contracts, let me show how to write a simple hello world contract in Java with this with our platform, and then I will go into the details about the lightweight contracts. So let's create a new class which will be our contract. This will be like, okay, let's say it's hello Java Summit. I will be doing the same, basically the same hello world contract that you already have here, but just I want to write it as I'm explaining it, so it's easier to understand. So basically it's quite easy. You just need to extend from abstract contract, and you don't need these two parameters in this example. This is just there is a mechanism to call a contract from another contract, and this relates about the parameters that go on in and out, but we are using one of the simple invocations or triggering of the contract. So it's the contract that will be triggered by a transaction that's directed to the contract. So for now, I can add optionally this annotation with the version. Let's call it version. I can override one of the different methods. We can have the process block. This will be executed for every block accepted on the blockchain. So this allows you to write contracts that doesn't depend on getting a transaction to them. So you want to check something in each block, on its n blocks, you can do it like here. Process transaction is the one that we are going to use, that triggers when a transaction is received by the contract. Process transaction, okay, I want to do something when I have a transaction. So first of all, you have this context here that you get with the as a first parameter. This is like the object, the proxy that allows you to talk to the node and the contract runner, which is the component that is running the contract. So if you want to query something or send transactions or get information about the transaction that has triggered this contract, everything is done through the context object. So for starters, I want to get the transaction that has triggered this contract. So let me store it like this. So this is the trigger transaction, and this will be a very simple contract that just is a hello world. So when you get a message from another account to this contract, I will just send a message back saying hello and the address of the account that has sent me the message. So that will be from the trigger transaction, the sender RS from the Ardor platform uses different ways of identifying an account. The easy and more visible one is the RS, the Reed-Solomon encoding of the 64 bits that identify an account. So that's what I'm loading. Like, this is the sender. So I want to send just a message back. So how do I create a transaction? We provide some what we call callers, which are a builder like classes that allow you to easily build and send transactions. So for example, there is a API call that's called send message, that sends a message on the blockchain. So we have a send message API. So we have also a send message call. So let's build a send message call, which is always created saying, okay, you need to put here the chain where you are sending this transaction. Remember, Ardor is a multi-chain transaction. So of course I want to use the same chain that I have received the transaction. So that's easy because I have this chain ID from the transaction. Then I want to send it to someone, and this someone is of course the sender of the original trigger transaction. And I want to send a message. So for this I'm going to use JSON. So let me first build the message. JO, it's like a simple object that encapsulates JSON. So for creating a JSON object, I just add a text and say hello and the address of the sender. Nice. So here I want to add the JSON string of the message as the payload of the message. So finally, I'm returning the transaction like this. So well, I need to write this call here like this. Let me send the call, and that's how it looks to send, which you can see it's quite easy to send a message back. So let me talk briefly about the technical details of how these contracts work. So these are the main key features, like they're stateless, so they can read and write in the blockchain, and so writing on the blockchain is like issuing transaction. We've seen that on the example. We read the trigger transaction, we read the account address of the transaction that triggered the contract, and we sent another transaction back. They're written 100% in Java. Our lightweight smart contracts code is not part of the consensus. Only the generated transactions are as usual. This means we don't need to place any limits on the execution time, number of instructions, or any kind of fees for the contract runner itself. The only fees are the ones paid by the transactions themselves, exactly like sending those transactions manually. So as I've said also, Oracle contracts that can interact with the external world outside of the blockchain are one of the major features of these lightweight contracts. So the example of the hello world, we've seen it. So the contract runner itself, it's just using the jar file or a class file that's stored on the blockchain with a custom class loader. So it pulls the code from the blockchain using a custom class loader, and then runs the code of the contract in a security sandbox, which means that the contract code is running under a custom security manager. We provide a mapping of blockchain entities like accounts or signatures, so the contract runner operator can fine-tune the permissions using a standard policy file. So this is, for example, a policy file that you can find on as an example, on the source code of the platform. Here you can see that the first one is just the default basic permissions for any contract, but you can also have specific permissions for contracts signed by a given account. This is the public key of an account, or for example from a given contract. So you see, writing smart contracts easily with Java is possible. Also, testing them should be easy. We provide JUnit helper classes, so it's really easy to unit test your contracts without even having to deploy them. For example, this will be the unit test for the same hello world contract that we've shown before. So that's all. Thanks for having me, and I hope you enjoyed this presentation.